Hello students, in this module let us discuss about the Vander Waals equation for real gases. Please subscribe my channel, like, share and comment my videos.
Vander Waals equation for real gases. In this module let us derive the Vander Waals equation for real gases. Ideal gas equation. Ideal gas equation is PV equal to nRT. So let us replace P and V by PI, that is pressure ideal and volume ideal. PI VI equal to nRT. Vander Waals in 1873 modified the ideal gas equation by introducing two correction terms, that is one for volume correction and other one is pressure correction. So volume correction, two assumptions we have to recollect in this context, two assumptions of the kinetic theory of gases. The first one is volume of the molecules of gas is not negligible when compared to the volume occupied by the gas. That is, the molecules are not free to move about in the entire volume. That is, ideal volume Vi is less than the observed volume V. So, ideal volume Vi is less than the observed volume V, that is Vi is less than V. Hence, some correction term is to be subtracted from the observed volume. Therefore, the correction term introduced by Vander Waals is V, that is small v. So, if the correction term is subtracted, then thus the ideal volume Vi is equal to V minus small v. So, ideal volume Vi equal to observed volume V minus correction term. The volume is to be subtracted. That is, the small v is the volume occupied by the gas molecules. So, V is proportional to N as per Avogadro's law. The volume occupied by the gas is proportional to the number of molecules. Number of molecules can be converted into number of moles. So, V is proportional to number of moles, or V is equal to NB, where B is the proportionality constant known as a Vander Waals constant, and the unit of V is liter per mole. The significance of B is called co-volume or excluded volume. B is called co-volume or excluded volume per mole of the gas. The unit of V already we discussed here. Unit of V is liter per mole, and B value, B is 4 times the actual volume of the gas molecules. Now let us see the pressure correction. Pressure correction. What is pressure? The force exerted by the gas molecules on the walls of the container is known as pressure. Since intermolecular attractions cannot be neglected. See, at high pressure and low temperatures, the gases liquefy. That is, the molecules come close to each other. When the molecules come close to each other, the intermolecular forces cannot be neglected. That means the molecules attract each other. As per kinetic theory of gases, the molecules of the gases do not have either attractive forces or repulsive forces. This is true when the real gas behaves as ideal gas, that is at low pressures and high temperatures. But when the conditions are reversed, that is when the pressure increases and temperature decreases, the molecules come close to each other, due to which the molecular distances decrease and intermolecular attractions will increase. Therefore, these intermolecular attractive forces cannot be neglected while we discuss the pressure exerted by the gas. The pressure exerted by the gas is nothing but the force exerted by the molecules on the walls of the container when they collide with each other and collide with the walls of the container. So due to the intermolecular forces, see here, this is the container and this is the molecule which is going to strike on the walls of the container. Therefore, this molecule is attracted by other molecules. They pull in this manner. Therefore, this is nothing but backward pull or drag. Backward pull or drag. So due to this backward drag, the molecules collide the walls of the container. Molecules collide the walls of the container with less force. With less force. Therefore, the pressure we observe is less than the pressure that is expected if there were no attractive forces. So the pressure we observe is less than the pressure if there were no molecular attractive forces, or otherwise, in other words, the observed pressure is less than ideal pressure. Observed pressure is less than ideal pressure. That is, P is less than Pi. Therefore, Pi equal to P plus P. That is small p. Small p is the correction term. P is directly proportional to the square of the density of the gas. But density equal to number of moles by volume. That is N by V. Therefore, P is directly proportional to N by V. Square of the density is N by V whole square. Or P is equal to A into N square by V square, where A is a proportionality constant, where A is the proportionality constant called Vander Waals constant. Hence, ideal pressure Pi is equal to P plus A into N square by V square. So what are the units of A? Units of A is bar, liter square, mole minus 2. Bar, liter square, mole minus 2. Now let us substitute this Pi Vi in the gas equation. So gas equation is Pi Vi is equal to nRT. What is Pi Vi? Pi is nothing but P plus AN square by V square into VI, V minus NB is equal to nRT. So this is a Vander Waals gas equation for real gases. This is the Vander Waals gas equation for real gases. Based on the Vander Waals gas equation, let us do a small problem. The problem is calculate the pressure of 154 gram of carbon dioxide gas in a vessel of 2.0 liter capacity at 30 degrees centigrade, and the Vander Waals constants A equal to 3.648 bar liter square mole minus 2 and B is 0.0427 liter mole minus 1. Gas constant R equal to 0.083 liter bar K minus 1 mole minus 1. Now let us see the solution. So Vander Waals equation is P plus AN square by V square into V minus NB equal to nRT. First of all, let us write all the information given. So here P we have to find, pressure equal to we have to find N. So first of all, mass of carbon dioxide given is 154 grams. What is the molar mass of carbon dioxide? Molar mass of carbon dioxide equal to 44 grams. Therefore, number of moles equal to given mass by molar mass is equal to 154 by 44 is equal to 3.5 moles. So number of moles of carbon dioxide given is 3.5 moles. Now volume of the vessel equal to 2 liters. Vander Waals constants A equal to, what is A given? 3.648 bar liter square mole minus 2 and B equal to 0.0427 liter mole minus 1 and gas constant R equal to 0.083 liter bar K minus 1 mole minus 1. So this is, let us substitute all these values in the gas equation, that is Vander Waals gas equation. So Vander Waals gas equation is P plus AN square by V square into V minus NB equal to nRT. Since here we have to find the pressure, let us rearrange this equation. So this is, bring this multiplying factor to this side. P plus AN square by V square is equal to nRT by V minus NB. Now bring this AN square by V square factor to this side. Therefore P equal to nRT by V minus NB minus AN square by V square. Now let us substitute the values in this. So what are the values here? N is 3.5 mole into gas constant 0.083 liter bar K minus 1 mole minus 1 into temperature. Temperature here we have to find, temperature is equal to T equal to 30 degrees. T is 30 degrees given. Therefore this T equal to 273 plus 30 is equal to 307 Kelvin. So in Kelvin scale we have to convert. Therefore T equal to mole minus 1 into 307 K by V, 2 liter minus N, number of moles 3.5 into constant B value how much? 0.0427. What is this? Unit is liter mole minus 1 minus, so here minus A minus AN square by V square. A is how much? 3.648 bar liter square mole minus 2 into n square. N square is 3.5 mole whole square by V square 2 liter. This is also whole square. Now let us cancel the units first. K minus 1 get cancelled, mole minus 1 mole get cancelled. So what is left here? If we simplify all this value, this we get 89.1835 liter bar by this is 2 minus 2 liter minus 3 point. If we simplify this becomes 0.14945. 0.14595. So this is a liter per mole minus 3.648 bar liter square mole minus 2 into 3.5 whole square is 12.25 mole square by 2 liter whole square 4 liter square. So liter square get cancelled and mole minus 2 get cancelled, right? So this becomes 89.1835 by, if we subtract this we get 1.8505 minus if we multiply this we get 42.483 by 4. So what is left here? Bar is left. So this becomes if we simplify this 48.1942 minus, so here 4 liter. So if you simplify this 42.483 by 4, this can be obtained as 10.62075. If you subtract this, the final value we get is 37.57 bar. So this is the pressure of the gas. This is the pressure of the gas.